Create a power series for x sine x centered at 0. And what is its interval of convergence? Now I notice I've got a product here, x, which is a polynomial, and polynomials are their own power series. Okay, their power series we studied long before we knew what a power series was. And they always converge, so you could say the interval of convergence is all real numbers, or you could say the radius of convergence is infinity. What else have we got? Well, sine x. Sine x has a power series, so it's like x minus x cubed over 3 factorial plus x to the 5 over 5 factorial, and so on. And it's got this nice general form. Okay, it alternates, so we can do minus 1 to the n, x to the, it's only odd powers, and we only divide by odd factorials. Okay. So x is its own power series, and sine has a power series like this, and if you remember, the radius of convergence is also infinite. Okay. Turns out if we multiply these two, we will get a power series that converges everywhere as well. Okay. Now, if you're worried about saying, well, product of these two, because they converge everywhere, will also converge, you can double check. It's not going to be hard to, the same technique for sine will work. So something like the absolute ratio test would do the trick if you really want to. Okay. But we can very easily multiply these two. We don't need to put any tables together or anything. Just bring the x inside. Okay. As far as the n, the index, is concerned, x is a constant. So everything involving n's stays the same. And then it's x2. We just increase the degree by 1. Okay. And just like the other two that converge everywhere, this will also converge everywhere. Now, they asked specifically for the interval of convergence, so we'll just say all real numbers. But the radius of convergence here is also infinite.